Hi, everyone. Jon Prescott with Scante, CEO and co-founder of Scante, which is a platform for IoT for machine builders and for industrial and commercial service providers. We're going to talk today about the IoT feeder pipe, essentially, for AI and machine learning, AI and ML. It's really a powerhouse. It is the absolute critical data that all OEMs, all manufacturers need in order to do the kind of targeted AI and machine learning analysis that is going to become what AI means for these manufacturers. And we're going to talk a little bit about that and some of the tools that you'll be using, at least give you some vocabulary for how to think about these problems. Because you're not going to be using Chat GPT and its many children in building out your diagnostic and predictive AI landscape for the kinds of things that most OEMs want to do. So, as I said, Scante is a platform for IoT data collection that focuses not on factory scale IoT, but on the relationship between machine builders and service providers and their end user customers. IoT devices that are on Scante are resident in people's homes, monitoring their generators. They're in factories, monitoring presses. And these are end user customer factories. And that data is flowing back to the press manufacturer with a data share between the two. They're in auto repair facilities around the country where they're monitoring pressures and flows in paint booths and reporting it to the paint booth manufacturer in order to service and maintain those booths optimally. So again, we're in the space between the commercial provider, the OEM of the machine or industrial services, commercial services, and the end user customer. Very different from most platforms. We're going to talk about the landscape here a little bit. We are in an artificial intelligence boom in a lot of ways, as you're, I'm sure, very well aware. And the odds are very good that you're using AI and ML, or at least AI, large language models, in your marketing, in your writing, maybe some in your automation. It's writing a lot of code these days. It's writing a lot of apps and these kinds of things. But there's very little being done with AI in small and medium-sized enterprises or smaller divisions of larger companies that is specifically focused on the machine, on optimizing the machine, on preventive maintenance, on monitoring and alarming, on new business models. And that's where, as I said, Scante lives. And it's where the data that is going to give you an artificial intelligence and a machine learning leg up is going to come from. That IoT data flow from your fleet of deployed machines is absolutely the critical piece of information that you need to enter that AI era. And without it, we think you're lost. IoT data can be a very large volume of data because your machines are generating that information on a continuous or mostly continuous basis, and it's ongoing. So the space where we work, you're selling a machine or you're engaging with a customer on one of their processes, and you're putting a monitoring system, maybe as part of the build initially, and maybe as an aftermarket improvement. And that monitoring system is helping you service and maintain that machinery. And it might be powering all kinds of business models for you, like long-term service agreements and so on, things like that we'll deal with, consumables, but certainly maintenance, warranty, all kinds of things like that. And that core data is going to be the data that you train AI models on, and you use machine learning techniques to analyze about your systems. Anything else is going to be large language models and marketing oriented, and AI is going to write a lot of things for you, but it is not currently set up to do anything other than these language-oriented tasks. It's possible, but not being done very much to have it do, program its own neural nets in order to look at IoT data. And so you need that IoT data in order to do these non-LLM AI tasks. So, a critical ingredient for competitive advantage, there's no question about that. The IoT data, if you don't have a large IoT data collection system right now with your fleet of deployed equipment at end user customer locations, you need to think about that immediately. You need to be gathering that data. You should have been gathering that data for years. I can take you back to Scante's marketing literature from 2013, 2014, and AI was kind of a gleam in our eyes, but we knew that it was going to become critical data for people, even if it was difficult to utilize at that time. It is more and more easy. And companies that have that database, that repository of many years of data about their equipment, are way, way ahead of the game. So if you embrace IoT as a driver for AI models, targeted, non-large language model AI, you're really going to be positioned for success moving forward. So again, not chatbots, not generative LLMs like Grok and ChatGPT and so on, but practical AI models and machine learning techniques. So these are based on real-time data from your deployed fleet, from your customers' machines, maybe test machines that you run in a tech center or something, but ideally in real production. And you're going to get production data as well as the IoT and sensor data from the machine, maybe the automation, maybe the drives and so on. And that's going to be used to train targeted algorithms for diagnostics and prediction. And that's what you're going to use. And these are going to be what are called regression models that are based on that data that isolate your use cases. So what are the metrics that you want to use, that you want AI to predict for you or to provide for you out of its work? These are typically going to be regression models based on these large data sets from the IoT. The data coming out of these things, it's going to be time series data. It might be vibration. I don't personally think vibration is the end all be all, even though in IoT it tends to be held that way. I think there are other things that are more critical and more predictive. Actually, I think vibration data is a little bit reactive. It's a strange thing to say because it's better than walking around the plant, but it's not as good as some of the things that get into the chemistry and get into the environmental system. But it's a starting place, and it might be for your particular applications. But temperature, humidities, event logs, failure tracking, usage patterns. This is going to vary by customer or by the customer's application, by your product line, and by the machines that you're monitoring. It's going to vary by the environment, the load, and operational parameters, but it can all go into the same sort of IoT database, and then these AI tools can look at it. Very important is failure data capture. So you need to structure your data so that you are capturing the events that lead to warranty claims, maybe including the warranty data for that particular machine, where you can relate then, or the systems can relate then, the day-to-day IoT sensor data from, say, servo drives and drive currents and operational and performance events to equipment failure, component failure in the machines. Maybe it's just the IoT data to machine performance. That's 100% valid. But anytime we can get failure data, we like it. And it turns out to be useful because those are the kinds of things you want to predict in advance. It's very high volume, it's continuous, and it can be very context rich. Now, it is not easy to set up IoT data collections to do this, but you need to have in mind that the reason you're collecting IoT data, in addition to sharing it with your end user customer and using that, sort of raw or moderately processed data in your own operations, you're going to train models to automate and scale the kinds of things that an expert looking at that data would discern. Because it's very hard to hire those people. It's not a cakewalk to train AI systems and machine learning tools for this. However, once you do, you can scale it. And those AI systems and machine learning tools can run 24/7 on those incoming data flows. And you don't have to find the next guy to hire and, train for 6 months or years in order to do that job, which is, that's obviously very difficult in today's environment. So the AI and the machine learning tools become, a real scalability system for IoT data value generation. Again, regression models. These are supervised and unsupervised reinforcement learning systems. And these are terms that you're going to want to have in the back of your head: supervised and unsupervised reinforcement learning. They are machine learning algorithms. We're going to help you build decision trees and do what are called vector machines, which are essentially looking at the spread of data in a mathematical way and determining the distance of all of these data, this cloud of data points, confusing, complex data, and determining what sort of the ideal walk through this data is. And then neural networks, which is the term you hear as the basis of large language models, neural networks are sort of the next evolution up from SVMs, from vector machines, in looking at unstructured big sort of clouds of data. And there are methods to walk through that data and come up with first sort of clusterings and groupings of related data, and then, real actionable decision out of that you can get from neural networks. And these are all things that are becoming available from cloud providers like Azure and like AWS, and companies like Scante are using these sort of generic tools that are available on a software as a service basis and tailoring them for OEMs and service providers, making them more easy to use and more use case specific to help you deploy them on your data. So these supervised learning tools, as I said, we're predicting failures using labeled data. This run from March 1st till March 17th is normal. And then we're going to be able to identify a faulty condition where we weren't performing as well, where there was a quality problem, where pumps were failing, where pressures were not right. And we're going to call that faulty. And we're going to supervise and we're going to identify good and bad operation. And we're going to build models out of that identification that are then going to be able to look in an unsupervised way at the incoming data flow. So that's a model. That's an AI model that's trained with supervised learning. Unsupervised looks more at a cluster of usage patterns, spots anomalies for itself without us labeling it as good or bad. And then, somebody has to come in and say, okay, this was good, or the algorithm is set up in a way that where the metric that you want is identified. We want good production, we want high quality, we want throughput in some variety out of these systems that we're monitoring. And unsupervised learning can look at that data and divide it up that way. And then reinforcement learning, also another tool you're going to want to have in the back of your mind and look up, where perhaps we're optimizing maintenance schedules or service interventions via kind of trial and error feedback. And we're building AI models that can then go back and look at the incoming data flow from tens of thousands of machines out there in the world on the basis of the few that we built the model from, right? So again, partly supervised, perhaps some unsupervised learning, but that reinforcement where we can identify success is how you build these models. And this is, IoT data is really ideal for machine learning for some of the reasons we've mentioned. It's structured, and we can, there's a label for a time series variable. It is time oriented, and we can do analysis on the basis of that time, those time intervals. And what we can go from is chaotic, multivariable data like what you see on the left there on the screen, and reduce that cloud down until we've got metrics, probably synthetic metrics, that calculated variables that we come up with or help you come up with, that are more related to your particular needs and use cases. This might be some kind of a change filter metric, or service the machine metric, or the likelihood, a metric about likelihood of failure. And that metric is created through the AI and machine learning tools based on a whole bunch of chaotic data. And that metric becomes the actionable item that you're sending alerts and alarms out for, or that you're reporting to the end user customer on a Monday morning, with their machine performance report. And there's a score, and that score is, what's the likelihood of machine failure in the next month, right? And it's going to move up and down based on this sort of cloud of uncertain data in the background that the AI models are looking at. You can see how this is very different from doing a ChatGPT prompt in order to get it to write your next blog post, right? This is math, but it is very doable, and the techniques for gathering that sort of evolve very naturally out of IoT data collection. Again, key tools: SVMs support vector machines, where we're looking at the cloud of data and its relationship to sort of normal and abnormal states. Decision trees that the AI models walk through with like go, no go, logic oriented nodes in the decision tree to classify the data as it moves forward on your particular use cases. Things like what are called random forests, where we have this big amorphous cloud of data, and we look at the principal components of specific PCA. That's a statistical technique and quote unquote AI technique that you can do, manually in an Excel spreadsheet with a small amount of data, or you can do on a very large scale using computing. And that's, really what you need to do in order to get the most value out of it quickly. So random forests is a term. And then neural networks. And this slide, we walk from the more simple to the more complex as we go down the list there, where we have small focused neural nets, not Grok, ChatGPT, billions of chips, hundreds of billions of dollars to train, but very small focused neural nets that are looking at a terabyte or 500 gigabytes of IoT data that you generated over the last 3 years that has failure data or throughput and performance data. And we want to optimize for a particular performance metric and say, this machine at this point is more likely to succeed than not, right? Or it's more likely or less likely to have a certain kind of failure. And those are all going to be dependent on your particular machines or the processes that you're servicing, your customers' experiences, and so on. We're going to look at the real data. Again, diagnostics, particularly bearing wear, particularly bearing failure from vibration data is a known thing. And that, instead of having the vibration analyst doing that analysis on, which is very expensive and slow, you may still do that, some of that, but you can feed that vibration data into an expert system, and it can be predicting conditions that you're specifically concerned about in your machines. So then product improvements, clustering of data from a large number of your customers out in your deployed fleet for perhaps design flaws, that are affecting production. These machines that had these configurations are performing this way, and these are performing that way, right? And you may have some people who know that and are, that's their job to identify that. But if you want to do that in a scalable way across 100,000 machines, it's extremely difficult to have, to find people to do that with the time and the folks too. But these algorithmic assessments can do that for you on an ongoing sort of 24/7 basis. Again, regression models, if you remember back to your college engineering classes, that are predicting future machine states, or use cases where we're converting complex sensor data into useful sort of synthetic calculated variables that are more specific, more appropriate for your use cases, and are more actionable for you to present to end user customers or your service team or your design team. We have a number of customers who are using these kinds of tools on their IoT data. We're going to talk really in briefly about these two and show you some pictures from one of them. Has allowed us to do that today. Relodyne is a key customer of ours. They're the largest distributor of industrial lubricants and services in the world these days. They're the largest distributor for Quaker Chemical and for Shell and Mobil and so on. It's a global wrap up of a whole bunch of industrial lubricant distributors. And we work for their services division, and they are using Scante systems to target initially sort of 30,000 roughly industrial machines in manufacturing and in power gen and other fields that they service, they provide lubricants for. And we're using some very complicated sensors that have been out there. They're electrical property sensors that work in the oils. And we're looking at that very complicated cloud of data and producing useful metrics using AI tools and machine learning algorithms that they can present as if it was lab oil analysis. So we're monitoring and producing oil quality metrics across their fleet in an automated way on a minute by minute basis for customers. So it's 24/7 without doing oil sampling and some other things that are extremely complicated and expensive to do. We can do with the install of a sensor and a cloud IoT data collection system running these AI systems. GFS is one of the leading manufacturers of paint booths in the world, based up in northeastern Wisconsin or northern Wisconsin. So it's a bit of a hike to get there, but very good people. And they are using Scante systems to target both their own paint booths and those of their competitors, monitoring them and offering long-term service agreements and services and consumables for those paint booths. So our systems collect data and help the end user to optimize the operation of that system and inform GFS service operations of the state of paint booth operation. Because these are usually, isolated, unconnected, fairly unautomated systems. And the Scante systems collect the data, pressures essentially, and the AI algorithms, the machine learning algorithms help to determine when the filter should be changed in order to keep quality high in the paint process and so on. So here's a couple of screenshots from the Relodyne application. In the center there, we have a dashboard for a particular, in this case, injection molding machine. And we're monitoring some variables. And a couple of them are synthetic variables. The QIA is a varnish. This is the moisture graph, but above this on the dashboard, we have a varnish calculation, and the ZDDP and the phenol are antioxidant additives in that oil, which we monitor very closely. And we use those sensors to come up with a real-time additive depletion metric. And these are AI, the ZDDP and phenol are AI synthetic variables that use this data. You can see on the right at the top, that 40-degree QIA data cloud is the confusing raw data that is discerned into, it's reduced down using the AI algorithms into those ZDDP and phenol metrics for that particular hydraulic fluid. And here, we can plot over time those values over large periods of time, multiple months, 6 months, a year, 2 years, and we can look at the trends from that using those AI tools. Nobody's having to do this manually. It's all automated and it's all available 24/7. So this is the kind of system that you can use, that you can deploy to your end user customers using these machine learning and AI models. In the Reladyne system, there are 4 or 5 continuously operating AI models that were trained on several years of data for oil quality across their services and their customer installations. Those models now are in a continuous improvement mode where every new sensor that they deploy to a customer becomes another data source that helps us to improve those models. And they become a continuously improving kind of a system. This is a serious competitive advantage. And AI is helping companies refine their products and refine their service offerings based on real world customer insights, and generating these predictions that are very dependent on your particular use cases. This builds a lot of customer loyalty. It builds a lot of stickiness around these applications because you're being very proactive in those diagnostics and using it to build trust. Our customers are generating revenue from these systems. However, the most widely deployed systems that we have are obviously, they're not charging customers $100,000 for this. They are, in fact, in some cases, giving it away, using it as a significant product differentiator and to get market leadership early in these systems. And they're maybe offsetting systems or they're embedding the costs into long-term service agreements, and they're using these sensor systems to drive the sale of long-term service agreements, which sort of levelize their revenue, and they can hide the cost of the sensors and the systems into those LTSAs, and they get wide distribution. Now, a few years from now, I think people are going to be willing to pay for some of these things because the ROI and the use case will have been fully demonstrated. But right now, I think it makes a lot of sense for companies to at least subsidize the install of these systems because it's going to turn out to be extremely valuable for you. And that's the experience of our customers. I can tell you tons of stories about this over, decades in IoT. And it's the same thing with AI and machine learning. The process here is to get your IoT connected products going and to get that data flow happening. We want the equipment, the machines that you manufacture and sell to your end user customers to have IoT gateways and to transfer that data back to a cloud location and to store and start to build your database. You can use that data to, for lots and lots of customer engagement, even before you can build AI models, but always keeping the goal that you are going to move to AI and machine learning once that data flow is fully established. Then you're going to be looking at fleet level data. You want to aggregate data across multiple customers. You want to then identify or in an ongoing way, identifying metrics or creating these predictive metrics, these synthetic metrics that you want for your use cases. And then you're going to test those models out, as that data flow builds. You're going to test and evaluate those models, and then you're going to deploy those models on the incoming real-time data. So there's a whole loop of AI and ML model creation that is going to be going on while you're collecting IoT data and hopefully using it for customer support from the minute it's available, but in the background, developing your models that are going to automate that process and take it out of the hands of your employees and just do it on a 24/7 automated basis. As IoT evolves, its role in shaping AI business models becomes more and more important. This is serious customer engagement tool, serious stickiness, serious provider of operational efficiency. The customer IoT data is the critical data for most machine builders and service providers, not their own factories, not their own production, the customer's data. IoT data driving diagnostics, driving service breakthroughs, timing, cost avoidance, warranty claims, etc. And the future really is data driven. We are getting to a point where we can use the IoT data. After decades and decades of collecting it, we can start to use it with these automated tools. So really step one is start to get that IoT data flowing and then start on the model development. Well, thank you very much. Happy to take some questions now. If anyone has any, appreciate your attention very much.
How will you use IoT and AI for machine learning? Let's discuss. Contact Jon Prescott at jon.prescott@scante.net or contact us to start a conversation at www.scante.net.